Okay, moving on into part 2 of section 6.3. We just finished learning how to construct the unit circle, and we noticed that the unit circle serves the purpose of a glorified reference sheet. It has angles measured in degrees and in radians, and it provides us with the x and y coordinates for every respective angle so that we can evaluate and find the value of trig functions. So we are going to dive right into that and see exactly how that is done. So first of all, there are some formulas that you will need to eventually memorize. So I'm going to move this screen down for a second, if I manage to be able to do that. Now, if you would take a moment, pause the video and copy these down, because you will be glancing at this continuously, okay? Now, I will be providing you with a printed out unit circle, and you will also be holding on to that because it will be used a lot moving forward, okay? Okay. Now that you've copied this down, currently I would like you to have your formulas and your unit circle accessible, okay? And I'm going to be referring to these quite often. We are going to start with the problems below and start working them out and seeing what I mean by that, okay? So here we go. First, let's look at the formulas and this unit circle. When I'm asking you to evaluate any of the trig functions, you're going to see that they are associated with a coordinate, x or y, or a combination, such as y over x or x over y, as you can see here and here, right? Or you will notice that they are reciprocals of the x or of the y. The x and y that they're referring to in our unit circle come from those coordinate values at each point. So, for instance, here we have an x and a y, here we have an x and a y, and so forth. Okay, all these coordinates, x and y, are what we are talking about when we are mentioning them here in the formulas. So let's practice using the unit circle to evaluate some trig functions. Okay, so we move to problem number 1. So you're going to see that they have asked us to find the value of sine theta. Now remember, I mentioned once that this symbol is pronounced theta, and theta represents the variable of whatever angle is being asked to find. So in this particular problem, we're asked to find sine of theta, and our theta, or our angle measure, is 90 degrees. Okay? Now, sine, if you notice down below in our formulas, sine is associated with the y coordinate found in our unit circle. All right? So sine 90 degrees, if you were to translate it in words, it automatically just means this. Find the y value, y value at 90 degrees. That's what sine of 90 degrees means, okay? So you will go to your unit circle, go to your 90 degree angle, and then go to the coordinate and eyeball your y value. The y value is a 1 at the 90 degree angle, so the sine of 90 is merely equals to 1. And you are done. Okay? I'm going to skip to number 3, since number 3 is right below us. And I'll just shift this formula sheet for a second if I can manage. Hold on. Okay, now that I managed to move the image of the formula, now what we're going to do is find the value now of cosine of theta. Let's go to number 3. So cosine of theta, we're going to write cosine of the theta in this problem is 270 degrees. All right. Now, if you go look at the formulas, cosine is attributed with the x. So what does this mean in words? And we won't have to write the words every single time, but I'm wanting you to do this just to get accustomed first. This simple sentence, cosine 270 degrees, means find the x value. Why do I keep putting values? At 270 degrees. So they provide an image here just in case you don't know how to find 270 very quickly. But if I go to 270, which is right here, and I asked to look for the x value at 270, that's this right here. So the answer to cosine of 270 is just 0. And you are done. And yes, it is actually that simple, okay? So let's try another problem. Let's go to problem number 2. All right, sine of theta is going to be, let's go ahead and do this. So sine of theta tells us to, whoops, I clicked the wrong thing. So substitute theta with the given angle, 240 degrees. Remember, sine just means find the y value. So you need to keep telling yourself that whenever you are doing these problems, okay? So if I go for the y value at 240, so here's my 240 in the third quadrant. I'm going to go to the y value, and that is negative square root of 3 over 2. So come over here, negative square root of 3 over 2 is my 240 degrees sine value. Okay. So let's jump down to problem number 4. Tangent. Tangent is a combination of our x and y coordinates. So let's do a little bit of extra math other than just looking at an x and looking at a y, because those are pretty straightforward as you can see. Cosine and sine, you just read off the unit circle what the x and y coordinate is. But tangent and cotangent, cosecant and secant, you have to do a little bit more work. So tangent in this particular problem is taking the value of a negative angle. So tangent of negative 60 degrees is what we're doing in this problem, okay? They give us a hint of where negative 60 is. But let's say they don't provide you an image, okay? Here's what I want you to recognize. So looking at our unit circle, you do realize that when we have positive angles, you always start at the 0 degrees and you rotate this way, okay? This was my 60 degrees. It was in the first quadrant, right here. I started at 0 and I rotate counterclockwise to get to 60. And I stopped right here. That was the angle measurement. If it's negative 60, that means you're going to travel the same distance you traveled here to get to 60. You are going to do the same distance, but you're rotating backwards. So negative 60 was this. In essence, negative 60 is the same as 300 degrees, okay? Because that's where it ends. So this is positive 60, and this is negative 60, because it's the same distance traveled, but opposite. So if I take the tangent of negative 60, I'm actually taking the tangent of 300 degrees, because that's where I stopped when I went backwards, okay? Now, tangent of 300, tangent means, okay, evaluate or find, why did that change my letters? Evaluate y over x at 300 degrees. Okay, so in our particular problem, let's go to 300. Our y and our x at 300 or negative 60 is this right here. Okay, my y is square root of 3 over 2 negative over, and my x is 1/2. So let's do that. My y was, I'm going to write it over here. Y was negative square root of 3 over 2, and then divided by my x is 1 over 2. Okay? Notice that. I'm going to put this in purple so you could see the division line. So this was my y, and this was my x. Does that make sense? Now here's the cool thing about dividing numbers in this unit circle. You do realize that your denominators are identical, right? So anytime you divide coordinates on the unit circle, your denominators are always going to cancel out because they're identical. So honestly, when you're dividing y divided by x or x divided by y, you don't really even have to pay attention to the 2's because they are going to cancel. So y was reduced to square root of 3 divided by x is 1, and negative square root of 3 over 1 is just negative square root of 3. So this is the answer to tangent of negative 60. And you are done. Okay? So let's try the next two. So tangent of 150, let's look at number 5. Actually, you know what? Why don't you try and do number 5? Pause the video and do number 5 on your own. Okay, you're back. Problem number 5. Tangent of 150 degrees. So as you know, it's supposed to be y over x. If you go to your tangent, to the 150 degrees, your y over x is this. So 1/2 divided by negative square root of 3 over 2. So that's what I wrote right there. Now remember, like I said before, start getting in the habit, not needing to have to write all of this. What you can straight up do is just go straight to telling me, well, and by the way, skipping that I just circled, y, well, the y was over here. Where was it? Probably, yeah, right here, which is 1/2. So you're just going to put 1, the numerator, over the x was this number right here, but we know the 2's are going to cancel. So just write the numerator value, negative square root of 3, okay? Because when you look upstairs, my 2's are going to cancel. So you end up with, well, there's that 1 over, and then there's that negative square root of 3. Okay, so no need to waste your time. But anyway, if you feel more comfortable writing the whole fraction, go right ahead. It's absolutely not a problem. Now, we have to rationalize this because we do not like radicals in our denominator. So we need to multiply. Why am I putting the negative? You don't have to put the negative. I'm just trying to get rid of the radical, not the negative. So square root of 3 over square root of 3. So that's going to give me 1 times square root of 3 is just square root of 3 over square root of 3 times square root of 3 is just a 3. And I need to bring my negative over. And then this right here would be my final answer for tangent of 150 degrees. So let's shift to number 7. I know I'm kind of jumping around everywhere, so bear with me, okay? So cotangent of 0, look upstairs to your little pink formula sheet. Cotangent is x over y, all right? X over y. So the angle they gave us was 0. So we're going to come over here to 0, and I'm going to circle all this just so it's catching our eye. We needed an x. The x is a 1. Divided by, we needed a y, which is 0. But can you divide by a 0? You cannot. It's undefined, all right? This is not possible. If you end up dividing by 0, it's going to be undefined. Okay, let's look at number 9, secant of 120 degrees. We haven't done any of the reciprocal ones, secant and cosecant, so let's do that one. Secant is 1 over x. Okay, so 1 over x. I want you to please interpret this fraction by saying to yourself, anytime you see this, read it as take the reciprocal of x. That's how I want you to read it. Don't say 1 over x. Yes, that's correct, but I want you to interpret it as take the reciprocal of x. So, looking at our chart, if we go to 120 degrees, so 120 is right here, okay? They're taking us to focus on the x value. This is my x value right there. But take the reciprocal of that. So the reciprocal of that means numerator becomes denominator and denominator becomes numerator. So secant of 120 is going to be 2 over negative 1. And because 2 over negative 1 can be simplified to negative 2, we're going to go ahead and simplify it. And you are done. Nothing else to do. That's your secant. So 1 over x means take the reciprocal of x. If you see cosecant and cosecant tells you to do 1 over y, that means take the reciprocal of y. Look at number 10. Number 10 is sine of 300. Sine means look at the y value. So I'm going to go to 300. Here's my 300. I'm going to look at the y value. My y value is negative square root of 3 over 2. So that is my answer. That's as easy as these problems are. I hope you're getting the hang of it. Let's look at another one. Here's number 6. Cosecant of 225. So how about you trying this problem out, okay? Let me just get you started, but I want you to do the behind the scenes evaluating and cleaning up of the problem. Cosecant 225 is 1 over y. So again, when you see 1 over a variable, I want you to tell yourself this means take the reciprocal of y, and in this particular instance, at 225 degrees. So pause the video, go do this problem, and then come back to me and see if you worked it out right. Okay, you're back. So 1 over y means take the reciprocal of y. I'm going to go to 225 degrees, and I am going to go find that y variable, and I am going to take the reciprocal of it. So 225 degrees, my y variable is this one right here. Take the reciprocal means flip it. So 2 over square root of 2. Again, it doesn't matter where the negative is. Oh my goodness. All right. Now, that's my answer, but I need to rationalize. Please don't forget that I do not want any radicals in the denominator. Make sure you rationalize. So my negative 2 over square root of 2 has to be multiplied by the numerator and the denominator by square root of 2. So 2 times square root of 2 is 2 square root of 2. They're not like terms. Bring the negative over. 2 square rooted times square rooted another 2 is just a plain 2. Now, I notice that these 2's can still end up canceling, and so I'm left with negative square root of 2 as my final answer. Okay? Cosecant of 225 is negative square root of 2. Okay? Turn over the page and go to number 11. Let's work another problem that has a negative angle. So the tangent theta, and theta is negative 5 pi over 3. So let's write that out. The tangent, substitute theta for the angle, negative 5 pi over 3. And let's go find where that is in our unit circle. So what I always tell a student is, look for where the positive one is first, okay? So pretend if the negative was not there. Where is 5 pi over 3? Well, 5 pi over 3 is right here, okay? There's where 5 pi over 3 is. But what I need you to be aware of is to get to 5 pi over 3, remember you start at 0. You started at 0, and you worked your way, oh no, we're doing radians, so let's start with the radians. Starting at 0 radians, and you're going to work your way around, because you always go this direction, go all the way to 5 pi over 3. And then you stopped, right? And here's where you stopped. So that's 5 pi over 3 distance. Notice you went through 1 quadrant, 2 quadrants, 3 quadrants, right? You went through the first quadrant, the second quadrant, the third quadrant, and you ended up in the 4th quadrant right here. You have to travel that same distance that you traveled in red as I'm going to do right now in purple, okay? So let's go in purple, but in the opposite direction because it's negative. So here we go. We travel, we travel, we travel, and we keep going past 1 quadrant, 2 quadrants, 3 quadrants, right? And then I go a little bit further to where? I go a little bit further to right here. I traveled the same distance. Do you see? That's 5 pi over 3 negative, the purple one. Does that make sense? So I'm going to erase that red one for a second. So we just traveled all this distance, but the negative was you traveling in the opposite direction. So that's your new angle. So where did I stop at? I stopped right here at positive pi over 3, at 60 degrees in other words. So tangent of negative 5 pi over 3 is the same thing as the tangent of the positive angle of pi over 3. Okay? So what does that mean? Well, tangent is y divided by x. So I'm going to go look at y divided by x at pi over 3. Remember, I'm only going to focus on the numerator values. So the y is square root of 3. The x is a 1. Okay? And what is square root of 3 over 1? Square root of 3. And you're done. That's as simple as it can go. Again, tangent is y over x. All right. Now, one thing, I'm trying to think of another way students do the positive and negative values of angles. Here's another way. Notice that this will always happen. Do you see how here this is 5 pi over 3? What some students do is they just jump over the axis. And if you jump over the axis, you will find the positive value of 5 pi over 3. Does that make sense? So that's another way that students do it, but just wanted to show you that you can do it that way as well. All right. Okay. Let's see if I can find another negative angle and then I can show it to you. Remember, tangent of negative 5 pi over 3, find the positive and then jump over, and then you will know which one's the negative. But let's see if we can find another problem. Okay, so I was looking for another example to show you how this negative angle works. Here on number 14, they already gave you the angle by showing you the display, but I wanted to show you what I meant by shortcut, okay? So number 14, they're asking you for sine of negative 4 pi over 3. So let's go ahead and write that. Sine of negative 4 pi over 3. So what I want you to do is find the positive angle instead of the negative angle. Let me show you both ways, okay? I'm going to show you both ways. Negative 4 pi over 3 means you're going backwards, okay? But let's look at where the 4 pi over 3 is, the positive one. So notice that the 4 pi over 3 is right over here, okay? How did you travel to get to positive 4 pi over 3? Not negative, positive. Well, I had to travel, I'm going to use my black marker on the radians. I had to travel from 0, and I had to rotate all this distance. Notice I went through first quadrant and second quadrant to get to 4 pi over 3. So that same distance is what I need to travel to find negative 4 pi over 3. So I'm going to pick a different color. Negative 4 pi over 3 means I'm going to start at 0, but I'm going backwards because it's negative. But I have to travel the same distance. So I knew I had to travel half a quadrant for sure, just like the black one did. But then I went just a little bit further to right here. That much difference. And then I stop. I just traveled the same distance in the opposite direction. So where did I stop? I stopped at 2 pi over 3. So that's my positive angle, okay? So the shortcut I'm saying, let me erase all this is, they gave you the angle to be negative 4 pi over 3, which was this right here, positive. So to find the negative angle, where the negative angle would have landed, jump over the x-axis and look where it would end, right there at 2 pi over 3. So you just look for it. And so by jumping over the x-axis, so sine of negative 4 pi over 3 is the same thing as sine of 2 pi over 3. And remember, sine means you're looking for the y value, and the y value at 2 pi over 3 is that, square root of 3 over 2. And you are done. Okay, there it is. Let's do one more, then I will let you practice. That would have been a full half an hour lecture, and I think you have heard from me enough. So, secant of 3 pi over 2. Secant is the reciprocal of x, right? Reciprocal of x. So we go to 3 pi over 2. Where is 3 pi over 2? Right here. And then we look at whatever our x is, right here. And we take the reciprocal of that number. Now, this one's weird, okay? 0 is the same thing as saying 0 over 1. So if I ask you to take the reciprocal of a whole number, first write that whole number as a fraction so that you know how to take the reciprocal. And any whole number just has to be written over 1. So reciprocal of x, so this is reciprocal of x. My x in this case is a 0. So 0 over 1 actually becomes 1 over 0. And as in the previous problem we've done before, this is an undefined value. So no solution on that one. Okay. Last but not least, cosine of negative pi over 6. So let's do the shortcut. So negative pi over 6, we want to change this angle into a positive angle. We want to find the positive angle on our unit circle. So how do we do that? Let's go to pi over 6, right? And let's find what that negative value is supposed to be. The negative value would have been here at 11 pi over 6. So cosine negative pi over 6 is actually the same as cosine of 11 pi over 6. Those are the same number. Okay? Again, cosine positive pi over 6 means you traveled that way. So negative meant you traveled backwards. And did you not end up at 11 pi over 6? That's what the shortcut said. And so cosine just means x. So we just need that value. So positive square root of 3 over 2 is my final answer. And that's it, my dears. That's how you evaluate trig function values at certain angles to figure out what it equals. Okay? No calculators at all are to be used because you're going to just get decimal values. Your calculations are all based on this reference of a unit circle. Thanks for watching.